area of quadrilaterals. Area of quadrilaterals. So initially we to start with, quadrilaterals are, what are quadrilaterals? They are bounded by 4 sides, maybe they are squares, maybe they are rectangle, maybe rhombus, maybe trapezium, etc., etc. So we will solve this type of problem, and I am again telling you that we will be solving some tricky and problematic sums, because each and every sum needs a huge time. But if you have any queries about any particular sum when you are going through your studies, your lessons, then please let me know. I will try to solve on for your convenience. Now, the sum number 1, a rhombus has its side 6 centimeter. So as you know, rhombus, should I tell you again? Rhombus is a quadrilateral or parallelogram rather, whose each side is equal but no angle is 90 degree. And here it differs from a square, as you know. So this is a rhombus, and each side, I have told you just that each side of a rhombus are always equal like square. But here the difference lies, the angles are not 90 degree. In case of squares, it is 90 degree. So this rhombus has its all the sides as 6 centimeter, and it is given that the one of its angle, let this angle is 60 degree. One of its angle is 60 degree. So we are required to find out the area of this rhombus. So we know there are some formulas for determining the area of rhombus. Area of rhombus equal to half into product of diagonals, as you know. I am not discussing it here. You will get you in your textbooks. The area of rhombus equal to half into product of diagonals. But here diagonals are not given. Only given the 4 sides and angle 60 degree. So what should I do? Should I draw diagonals? If I draw a diagonal, then what should I do with it? Because there is no 90 degree angle, this is 60 degree, and another diagonal I can draw. But what is the benefit? That we have to think over, because we know this generalized formula, half into product of diagonals, both the diagonals. Because we know in case of rhombus, the diagonals are unequal. Okay, diagonals are unequal. So if it is one of it is 3, one of it is 4, then 3 into 4, 12 into half 6, you can easily deduct. But here the diagonals are not given and there is no way to deduct the value of them as such. So better to take a different way. What is it? Draw again the rhombus. Six, 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 A, B, C, D. Regarding the nomenclature of that vertices, I need not repeat you all. Maybe I hope you know all that it should go always in some symmetrical way. When we marking this alphabetical in nomenclature, then it should be either anti-clockwise or clockwise. So A, B, C, D, not A, B, C, D. Don't do like that. It will create some confusion. So it's better to nomenclature. For nomenclature, either you take anti-clockwise or clockwise. A, B, C, D, like that. So A, B, C, D is that rhombus, and here is the angle. As I told you, it is given that 60 degree. So given sides of rhombus ABCD equal to 6 centimeter, and second, one of the angle equal to 60 degree. That's all given. And what we need to prove? We need to rather deduct area of the rhombus. So as I told you earlier that these formula we cannot apply here because the diagonals are not there, and if we draw diagonal then we have not any way to deduct their values. So we take a different way, as I told you earlier, that we do some construction. From A, I draw a perpendicular. Let it be E. Let it name as E. And from D, again a perpendicular. It is joined and let it be F. So, I draw here a perpendicular AE. Here I draw a perpendicular DA. So if you study this diagram, then you can see that here is rectangular figure has come out. What is it? AD, AEFD or ADFE. As you see, AEFD, ADFE, like that. It is a rectangular figure, out of which one of these rectangular figure, this length we know, it is equal to the rhombus itself. But what we require to find out is the area of the rhombus. So now we draw perpendicular here, so it is 90 degree, and it is also 90 degree. And this is 60 degree, so this is also 60 degree because these lines are parallel. As you know, in case of rhombus, AB and CD are parallel, and the transverse is BC, so the angles must be equal, 60 and 60. So now, other day, I told you several times that whenever in a triangle you see in a right angle rather, in a right angle triangle, whenever you see a 60 degree or 30 degree angle, then there is a trick, there is a formula, there is a theorem. I hope you remind, you can guess. This is 90, this is 60, so this is 30 degree. This is 90, 60, I told that 180 total degree, total angles of a triangle is 180, so this is 90, this is 60, so 150, so the other angle should be 30 degree, it is 30 degree. So I told you that whenever you see any right angle with a 60 or 30 degree angle, because if it is 90 degree, it's already given. So if it is 30, then other angle should be 60, and if it is 60, then other angle should be 30, because the total angle should be 180 degree. So here also the same thing applies. So what we told that day. So from triangle ABE, BE is the side opposite to the 30 degree angle, so it is half of AB equal to half into 6 equal to 3 centimeter. So this is 3 centimeter. BE is 3 centimeter. Okay. Now the question arises, what is the need to know BE? Because we are concerned with the rhombus. It is not the rhombus, it is the part of a triangle, but it is included in the rhombus. And the main motto is that the rectangle, as I told you earlier, the one of its, that's length is 6, but this side of the rectangle we don't know. But now we can easily know, because this is 6, this is 3. So we can easily find out the value of AE from what we told, that for any right angle triangle, again this ABE, Pythagoras theorem the other day, you all know Pythagoras theorem, that the perpendicular square equal to base square plus hypotenuse square equal to the base square plus perpendicular square. So AB square equal to BE square plus AE square. What we need to find out here? AE. So AE square equal to AB square minus BE square equal to AB, we know it is 6. So 36, 6 square 36 minus 9, 3 square, that means 9. So 27 AE square. So AE equal to root over 27, that means 3 root 3 centimeter. 3 root 3 centimeter. This length is 3 root 3 centimeter. I again repeat, from this triangle ABE, the other day I told that if any right angle triangle having a angle either 60 or 30, then or the side opposite to the lower angle is half of the hypotenuse. So here also BE is the side opposite to the lower angle, it is half of the 6, that is 3 centimeter. Now this particular right angle triangle, this side is we know, and we have just deducted B equal to 3. So we need to find out these value AE, and how? Applying Pythagoras theorem. By applying Pythagoras theorem, we find out that it is AB square equal to B square plus A square, and by solving by transposition we find out that AE equal to 3 root 3 centimeter. But why did you find it? Because the rectangle had its length, breadth was not known to us, but now we know the breadth. But here the question arises, why we are interested with the square, rather the rectangle. Why we are interested with the rectangle? We are supposed to think about the rhombus. But why we are wasting time on this rectangle? Because that's the main clue of this sum, friends. You just go through your books and you will get a theorem. It's a basic theorem. There is a basic theorem that whenever two parallelograms lie on the same base and in between same parallel lines, then their areas are equal. That is the famous theorem. I again repeat, whenever two parallelograms lie on the same base and in between same parallel lines, then their areas are equal. And I told you that in this rhombus there were no diagonals, so we had not any direct way to find out the area of the rhombus. That's why we have to draw some rectangle, some perpendicular to form a rectangle, and from the rectangle's area is the area of the rhombus. That's what was our intention, to draw the rectangle and to find the area of the rectangle. So now the area of the rectangle, so area of AEFD into rectangle equal to length into breadth, 6 into 3 root 3 equal to 18 root 3 square centimeter. So the area of rhombus equal to same 18 root 3 square centimeter. You have a confusion. I think you have a confusion. Where is the base? Where is the same base that on which the both of them lies? If just tilt. If I tilt this board, you just imagine this is as the base. For your convenience, you just imagine this is the base AD. The original rhombus is this, and we have drawn these two perpendiculars, so this is the rectangle. Both of them lies on the same base AD, and in between same parallel lines AD and BF. So their areas must be equal, and that's what we have done. I think that's clear to you.